So we're gonna move past just simply converting to actually solving some problems here, right? And I'll be giving you some extra information along the way. You good? I know it's Monday, and you're like, I just did all this work. More work? Right? Fortunately, I have to keep going. Right? I wish I could take some breaks here and there, but word problems will often require you to apply the skills learned above. Once given a rate, you can use it to set up a proportion, right? Maybe I should highlight that part. Okay. Once you're given a rate, you can use it to set up a proportion. Two equivalent fractions that have an equal sign, right? So a car travels 50 kilometers per hour. This is where we touch on the problem that I gave you on the AC. And I might have to adjust. I know I'm going to look at it and I will adjust accordingly. A car travels at 50 kilometers per hour. How many miles can it travel in 7 hours? Right? It says miles. Like, what's up with that, right? You're going to have to convert. So you decide how you want to do it. That's the tricky part, but the beauty of math in a certain degree, right? So how did I do it on my key here? Yeah, I just went like this. Watch. I went 50 kilometers in 1 hour. Okay. No times. I'm going to say equals. Right. If this is true, right? How much would I cover? Right? How many kilometers would I cover in 7 hours? Right. So this rate. What kind of a rate is this? Just a rate, or is it a unit rate? It's actually a unit rate because it's 50 kilometers per 1 hour, right? So just to get the technicalities, it's both. It's a rate and it's a unit rate at the same time. But I started with this, right? And then I set it to a proportion because, right, out of kilometers and hours, they're giving me the hours. I'm trying to figure out how many kilometers that would be, right? So I always, when it's a proportion like this, I start where the variable is, right? That side, and I go to the number, I cross multiply and divide. And some of you are going to stick with your old method. That is just fine. 7 times 50 divided by 1, right? 7 times 50 or 50 times 7, it doesn't matter. Just multiply them. And then last step is to divide. That is important to remember. So that would be 350. We are expecting it to be kilometers, right? So that would be like the first mark, the conversion. Okay? But it asks for miles. So we're going to go 350 kilometers times, right? 1 mile has 1.6093 kilometers. Easy peasy, right? So it's essentially 350 times 1, which is 350, divided by 1.6093. And my answer is 217.49 miles. Okay, this is the ultimate, this is like your final answer there. So, Mr. Erickson, could I have converted 50 kilometers per hour to miles per hour? And then, yes, right? You could have done it whichever way you choose. Just show me your logic, right? Show me what happened. And in fact, watch what I'm going to do. Just have a line there, right? This is step 1, then step 2 there. So try to organize your work so that it's easy to read. And watch this. I introduced a variable. So I'm saying, hey, that variable is equal to this. That variable is equal to that. Here, there is no variable, right? You're just simply doing a conversion to state the same distance in different units, okay? you try B real quick, and then I'll take over. Same idea, just give it a quick try. I'm not going to give you a whole lot of time. Okay. I'm going to get going here. A small bolt motor uses 2.4 liters every 3 hours. Right? How many gallons, right? How many gallons will be required to run the motor for 12 hours, right? This is a rate, okay? Is it a unit rate? No, because it's not per hour, it's per 3 hours. So just trying to get you to think about that. Does it matter on how we operate? Not really, okay? So there's a problem here. We're given liters and for 3 hours, but they want gallons for 12 hours. So how do we deal with this? I'm going to figure out how many liters in 12 hours, and then I will convert, okay? So how many liters in 12 hours? That's what I'm going to answer first. So 2.4 liters. Don't erase if you did it the other way, right? So then 12 hours would require X number of liters. Okay, so you go cross multiply and divide. So 12 times 2.4 divided by 3. And I'm just going to show you here. That's 9.6 liters, right? No rounding necessary there. In 3 hours, right? So the next step would be 9.6 liters, right? I'm going to turn that to gallons, right? So 1 gallon has did I tell you 3.79? Did I give you that? Yeah? Okay. 3.79 liters. Cancel, cancel, right? So you basically just take the 9.6 and divide it by 3.79. 2.53 gallons. Okay. That's how many gallons of fuel you would need to run the motor for 12 hours. Okay. Okay. Here, when we're determining the better rate, the best way is turn it into unit rates, right? When I'm asking you which one is better, which one is faster, make sure you have them both in unit rates. Units need to be the same, so convert as needed. Determine the unit rate. Basically, you go numerator divided by denominator and state the better rate and by how much. Okay, so here's an example. You go to the store, you see that, a bag of apples, a 3-pound bag of apples costs $2.99, right? How would you turn that into a unit rate? Well, you would go $2.99 divided by 3, okay? So you take your calculator, $2.99 divided by 3. So that would round to $1, right? This 6 bumps this to a 10, bumps this to a 10, bumps this to a 1. Okay, so that would effectively be $1 per pound. Okay, this is what we prefer, right? $1. Can I just say that here? $1 per 1 pound. That's what you're basically saying. Okay. I'm also going to say this. When money is involved, find the dollars per unit. So dollars per gram, dollars per liter, dollars per pound. Some students flip it, and then it's actually saying how much would it be for $1, right? How much could you get for $1? And I would like to have cost divided by quantity. Okay, so remember that. Cost divided by quantity. Here's another one that will come up from time to time is fuel economy. Okay. Is he switching up highlighters on me? Yeah. The amount of fuel used per distance traveled, usually stated as liters per 100 kilometers. And this could come back in grade 12 applied. So I'm going to give you a formula, right? So this should be on your study sheet somewhere. I'm going to call that fuel economy, right? You take your distance in kilometers, like the distance you traveled, and you divide it by the liters, right? Liters L, and you multiply that by 100. And I'm going to call that underneath here. I guess I'm just going to go arrow, fuel economy. That's how you would find it. So you take, hey, did you travel 350 kilometers? You take that, you divide it by how much you fueled up on your gas tank, and that would give you your fuel economy for the vehicle. In Canada, we state it as liters per 100 kilometers. Okay. So let's keep going. I'm going to go first and look up fuel economy just in case I run out of time. So let's go to page 7 at the very top. Because I know a lot of you are comfortable with money. With fuel economy, you don't do that on a regular basis, right? Some of you are going to start driving, some of you are driving, but still you don't necessarily think of this on a regular basis. Which car has the better fuel economy? So this is, you should be thinking FE, right? Where's my formula for fuel economy? Where is that on my study sheet? I hope you transfer it, right? Car A uses 32 liters to travel 500 kilometers. Car B uses 11.5 gallons to travel 300 miles. You're like, wait a minute, I don't like this. I can handle liters, kilometers, because you just gave me a formula, but gallons and miles, what's going on there, right? So how about we do car A first? Car A, I'm going to figure out the fuel economy because everything I need is there. Okay, 32 liters divided by 500 kilometers times 100. So let's figure out that fuel economy. So 32 divided by 500. When you divide this, you're finding a unit rate. You're finding that you need 0.064 liters for every kilometer, and that's not very helpful to us. That's why we go times 100. So this car would be using 6.4 kilometers. Sorry, my bad. 6.4 liters per 100 kilometers. That's just the standard way of stating fuel economy. Okay. For car B, we need to do some converting. So let's do that real quick. 11.5 gallons times 1 gallon has 3.79 liters. Cancel, cancel. That is 43.585. Watch this. I'm leaving all 3 decimals in here. I'm not rounding yet. If it had continued, it would have gone dot, 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 right? Meaning I'm using all decimals. And I'm also going to convert my miles, 300 miles, to kilometers. 1 mile is 1.6093 kilometers. Miles go with miles. That's 482 0.79 kilometers. And now I have liters and kilometers. Now I can use that formula to figure out the fuel economy of that car. So 43,585 liters divided by 482.79 kilometers times 100. And I'm just going to answer that. Normally, I don't like choo-choo trains, especially when it's a proportion. Don't do that. But in this case, you can do it, right? Because you're computing this and then just saying what the answer is. So you can copy paste, right? Remember that? Go up, enter, divide it, go up, enter, and then multiply that answer by 100. So this car uses 9.03 liters per 100 kilometers. Which car has the better fuel economy? If you think about it. I would like somebody in this room to answer that, to be brave enough. Which car is better? Which one would you pick if you had to pick a car? Car A? Can you explain why? Less fuel. That's right. Sander got it right. Car A is better because it uses less fuel to drive the same distance. You see that, right? So it's better, right? So you have to answer it that way. And I used up all my space here, but car A has the better fuel economy. And watch this, it's a little weird, but we're gonna say by how much. So I do a little calculation on the side here, watch this. 9.03 minus 6.4, okay? And it's Monday morning, I don't wanna make mistakes, right? So liters per 100 kilometers. So I just showed this on the side here. I don't expect you to do this on the side. I'm just showing you how I come up with this. So 2.63 liters per 100 kilometers. So that's about 2.63 liters of gas right now. Multiply that by 1.65, right? That's the gas price right now. So $4.33 to 34 cents for every 100 kilometers you drive that you'll be saving. Okay, it's not a whole lot, but hey. So this is a fuel economy. I think, I don't know, I'm gonna highlight the fuel economy part here so you have an example, right, when you flip through your notes. So Mr. Anderson, question. What if for car A I had converted the liters to gallons and the kilometers to miles, right? So I had miles and gallons, and then just use these ones here as is. Would that be okay with you? Yes. But I usually tend to go to liters and 100 kilometers because that's how it's done in Canada, right? Miles and gallons would be the US. Okay. What I want you to get from today's lesson is the fact that we're mixing up converting with, right, answering a question which is going to ask you to do some kind of proportion, okay? And you mix and match as you see fit. However, I'm not done yet. Like, why does he talk so much? I just want to give me the homework and let's move on, right? I want you to know that here you could have set up a proportion as well, but with fuel economy, I just gave you the formula because it's very standard. It's used throughout in various courses, so that's why I just gave you that formula, okay? I think for now, I'm just going to give you some I want to give you some class time, but I want to maybe do one more here, just so you can't say I didn't give you enough examples. So let's go back to page 6, which is the best buy, right? Or the better purchase, right? And by how much? Watch this. Which one is better and by how much? Okay. Yeah, we're back to page 6. I just wanted to make sure I had a fuel economy in there. So a 12.8 kilogram turkey at Safeway, or a $42.89, sorry, this much turkey for $42.89, or $1.49 per pound at Superstore. Which one is better? Okay. Well, I'm gonna focus on get a unit rate. Okay. Focus on getting a unit rate, right? Make sure units are the same. Okay, that is important. How you do it, it's up to you. Okay. So I tend to break it down like this. I'll have Safeway here and Superstore on the other side. Does Superstore already have a unit rate? Is that a unit rate, $1.49 per pound? It's so I won't touch this one. I'll leave it, right? $1.49 per pound, already a unit rate. So I'm just making an observation like, hey, why would I touch that if it's already the way I want it to compare? So I'm going to focus on Safeway. Okay. Which one goes on top? Dollars or kilograms? It's always cost divided by quantity. Okay. So dollar amount, I would say 42.89, 12.8 kilograms. So I'm going to try to make this one to be dollars per pound. That's my ultimate goal. So the first step is going to be, well, dollars I don't want to change. I just want to change this part. So 1 kilogram has what? How many pounds? You should have that on your study sheet. 2.2 pounds. So I can cancel kilograms with kilograms. And let's just get this one figured out. 42.89 times 1 would be 42.89, you guessed it, over, let's figure out the denominator here. 2816. 2816 pounds. So you're close, you're dollars and pounds, but it's not a unit rate just yet. Okay, unit rate would be 42.89 divided by 28.16, and that is what you want. You get $1.52 per pound. Okay, now we're talking. Okay, now both are unit rates and both are in pounds, right? You could have done 42.89 divided by 12.8 kilograms, but then it would have been dollars per kilogram, not good enough. So which one is better? Superstore, right? Superstore is better by, and here you have to do a little bit of math on the side maybe. It's 3 cents, right? 3 cents what? Some students just leave it like that. Hey, it's 3 cents cheaper. In this case, for every pound you buy. Okay, so we go like this. Just stick with the units you already have, and there it is. Is it worth going to Superstore if you're already at Safeway? Probably not. You spend more on gas, right? But it is, in this case, cheaper. So focus on conversions that are necessary. Be smart about it. Okay. Mr. Erickson, could I have just converted this to dollar amount per kilogram? Yes, you could have, but I chose to just leave it as is. Okay. All right, I'm going to stop there. And let me just check here. I'm just going to ask you to finish page 6 and 7, but 7 has a question that sneaks into page 8 at the very top. So I will just say this: homework, page 6 to 7, right? And by that I mean just the top question on page 8. Do that as well, right? It's a continuation of the last question on page 7. Okay, that's not a whole lot, is it? It's not a whole lot. I felt like I talked a lot. You're a bit overwhelmed maybe with the AC, all of that, right? So we're gonna just ease our way in. But tomorrow I'm gonna start talking more renovations. Okay, that's a bit of the heavier part. So we're gonna do some renovations, surface area, stuff like that.